My name is Trilla Dinesh from CSITA section. My tech talk concept of programming with objects is memory management in Java. Let's see the first. Why to learn memory management? Everyone knows that Java maintains memory on its own. Doesn't require a programmer explicit assistance. Garbage collection guarantees that memory may be released when not needed and that unused space is cleaned up. Not everything is ensured by automatic waste pickup. If you don't understand how memory management functions, we frequently find ourselves dealing with JVM management managed object. Some items cannot be collected automatically by garbage disposal. Understanding memory management is crucial because it will help programmers create high performance systems that do not crash, or if they do, know how to troubleshoot or fix them. Introduction. In Java, memory management is the process of allocation and deallocation of objects called memory management. Java does memory management automatically. Java uses an automatic memory management system called garbage collector. Thus, we are not required to implement memory management logic in our applications. Applications. The Java memory management is divided into two major parts: JVM memory structure and working of the garbage collector. JVM memory structure. JVM creates various runtime data area in heap. These areas are used during the programming execution. The memory areas are destroyed when JVM exists, whereas the data areas are destroyed when the threads exist. Method area. The heap memory, which is shared by all threads, includes a section called method area. When the JVM starts, it creates the name of a superclass, the name of an interface, and the constructor are all stored there. It includes elements specific to each class, includes fields, constant, pools, method, local data, method codes, constructor codes, etc. that are used to initialize objects and interface. The Java virtual machine throws an out of a memory error if the memory in the method area cannot be made accessible to satisfy an allocation request. Heap, heap area. The objects that are produced while a Java programming running are kept in heap memory. The reference to newly formed object is kept in stack memory. Dynamic memory allocation is followed by heap is allocated during execution of runtime. When compared to stack, heap memory is large in size. The garbage collector automatically removes an unnecessary object from the heap memory. The heap's memory does not have to be contiguous. JVM gives the user the option to initialize or change the heap size as needed. Heap is divided into the following parts: young generation, old generation, permanent generation, and survivor generation. Survivor space and code catchy. Now we'll see that young generation, all new objects are assigned and aged in this location. When this is full, there is a small garbage collection. Old generation, long lasting items are kept in this location. Permanent generation. These comparison this compresses JVM metadata for the applications, methods, and runtime classes. Survivor space and code cache. Now we will see about stack area. When a thread starts, the stack area is generated. It might have a fixed size or a variable size. Each thread has its allocation of stack memory. Data and unfinished results are stored there. Furthermore, it stores the value directly rather than a reference to an item from the heap. The item scope refers to the visibility of the variable that are kept in stack. Native method stack. Native method stack, often known as a C stack, are not created in the Java programming language. Each thread receives a memory allocated allotment when it is formed. Furthermore, it may have a fixed or a dynamic nature. Programming counter or PC register. PC register is linked to every thread. A native pointer or to return address is kept in the PC register. It also includes the location of a JVM instruction that are now being carried out. Now, working of garbage collector. The garbage collector is managed by JVM. When to do garbage collection is determined by JVM. Additionally, we can ask the JVM to activate the garbage collector. If JVM detects that memory is running low, it starts the garbage collector. The JVM often responds quickly to requests from Java programs for the garbage collector. The time it takes the gathering garbage grows as the more things are generated and added to the garbage list. The objects are divided into groups and given an age based on how many clock cycles they have endured. This way, the garbage collection works gets distributed. Now we will see that Java have five types of garbage collector implementation. First is serial GC and parallel GC, garbage collector, parallel garbage collector, garbage concurrent mark sweep collector, and G1 garbage collector and Z garbage collector. Now we will see the serial GC. It mostly releases on the single thread. This is the simplest GC implementation. Because of this, whenever this GC implementation executes, all application threads are frozen. Parallel GC, it refers to as a throughput collector and serves as the JVM default GC. It uses several threads to manage memory space, but it also processes other applications in threads while doing GC. Concurrent mask sweep collector. Multiple garbage collector threads are used by concurrent mask sweep garbage collector to collect garbage. It analyzes the heap memory to identify instances that should be swept. Then it marks such as instance for fiction. G1 garbage collector. G1 garbage collector is made for programs that use multiprocessor computers with a lot of memory. It divides the heap memory into selections and performance parallel collection within each one. Just after reclaiming the memory, G1 simultaneously compact the free heap space. Z garbage collector. Z garbage collector is appropriate for application that demand low latency and or apply a very large heap since it executes all expensive work concurrently without pausing the execution of application threads for a longer than 10 millisecond cycles are completed by Z garbage collector in this thread. Conclusion. Memory management in Java refers to the process of allocation and freeing up space for objects. The Java memory model explains how thread communication with one another through memory in the Java. Programming languages. The Java memory model explains how thread communicate with one another through memory in the Java programming language. The object of programs are stored in various locations In the JVM memory store, the process of freeing space in the heap for the allocation of new object is known as a garbage collection. Thus, understanding memory management is crucial because it will help programmers create the high performance system that do not crash, or if they do, know how to troubleshoot or fix them. Thank you.